All right, up here we have a carbocation. But the question is, where is the positive localized? We see it's just there in that structure, but theoretically it could be in more locations. Also, might as well do this for two molecules. There's another one. How many carbons have carbocation character? 1, 2, 3, 4, or 5. So pause the video, try and figure that out for yourself, and then turn it back on, and we will draw those structures. All right, you did it. Okay, so we're going to number this around, and this should look really familiar. We've already kind of done this with radicals, but now we're just moving 2 electrons at a time instead of with radicals, we were technically moving 3 at a time. So that pi bond can move up there. That would put the carbocation here at position 3. This bond can move down here. That would put the carbocation here at position 5. Are we done? No, we can keep moving it. That can move over there. It's the carbocation there, which is technically now position 2. And then we can move it one additional time. Technically, we can move it an unlimited amount of times. And that would put the carbocation here, which is now position 4. So the answer is that all 5 carbons have carbocation character in this molecule. If we wanted to draw it more in reality, what we would need is a pi bond on all, a p orbital on all of these locations, and there would be delocalization above and below the plane, connecting all of those carbons to the positive charge, and that's how it's delocalized over all of those 5 carbons. What about this down here? Hopefully you've already drawn those. It should be 3 different locations. Technically, we can just move that over there. Puts it there. We can't move it through here, right? Because we can't have any conjugation through an sp3 orbital. So to move it farther, we would have to move both of those arrows at the same time. That would put it at this location. So technically, it is delocalized over 3 carbon atoms. So that's how this conjugation delocalization works. This should be, again, pretty familiar from all of that radical character stuff. So great job.